Yes, ma, can you see the screen? Guys?
Yes, sir.
Yes, you can see. A lot of syllabus is there. Okay, so we're looking at the stack. No, before going to the stack, anything is there? Yes. We are talking about the vector. So vector, so the vector is a legacy, and then you can apply. So if you want to add an element to the vector, you can use add element method. Okay. So remove element, add element, all these methods are there. Right, you can see here. Okay. So all these methods are applicable for vector. So have a look on this. And so you can, I mean, this vector can use all the methods of, okay, its own, and then it can also use the methods of the list interface, and also it can also use the methods of the collection interface. Okay, so any of the suitable method, if you find for your requirement, you can always use it. Okay, so first you prefer the methods of the its own, like vector class. If you want to add the element at the beginning, you write the use the first element method. If you want to add the element at the end, you can prefer last element method. So, and at some position, if you want to insert the element, you can always use the element at method. Okay, so this way I have already seen. And then if you look at the constructors, you can see the vector v is equal to new vector. So it's a default constructor. So the default constructor initial capacity is 10. Okay, you can see here the default capacity is 10. Okay, initially we'll get the vector of size 10. So if you want, if you are keep on adding the elements beyond these limits, so then its capacity is going to be doubled by default. So it means new capacity is equal to current capacity into 2. Means its capacity is going to be doubled. And so if you have any special requirement, you can use vector v is equal to new vector of, so int initial capacity. No, I don't want 10 as my capacity, default capacity. I have special requirement. I know that I'm going to add so more and more the values to this. Then I can use my initial capacity. And also this is one kind of constructor. Either you can use this constructor or you can use this constructor. Based on your requirement, you can choose the constructor. And then vector v is equal to new vector of, so you can mention the initial capacity. After the initial capacity is exhausted, so what is the how much size is to be incremented, that you can mention incremental capacity. Okay, so the incremental capacity we mention as so a double value. So otherwise you can say incremental capacity into value you have to mention, like, so I want some 20 elements, 30 elements, you can mention that way. So one more important constructor is, so always any collection object, so will give the support for this constructor, right? Array list is giving, array list is taking another collection object as an element. So and the linked list is also taking another collection object as an element. And this the vector is also taking another collection element as, I mean, another collection object as element of its own, right? So this you can see. Yeah, you can see here. So a small demo program, vector v is equal to new vector. So if I ask system.out.println v.capacity, its capacity is going to be 10. And so if I want to add the elements to this vector, I can use add element method. Now I am iterating through. So for, I mean, 10 values I want to add. That's why this for loop v dot add element of I 10 times. This is going to be executed, so that so 1, 2, 3, 4, 5, and so on is going to be added to the vector. And then so once it is done, if I ask what is the capacity, it's going to be 10. Again, after the 10, if we add at least one element, its size is going to be doubled. That is, so after adding 10 elements, v dot add element of A, I am adding a string object. Now you check what is the size of this vector. System.out.println v dot capacity. Here you can see. Now the capacity is going to be. Now the capacity is going to be what? So 20, right? And then you can see the elements. System.out.println. So directly you are printing it. Okay, that object you are printing. So next one more class, which is a child class vector. So that is stack. So the stack is a child class vector, and then the properties of stack we already know. This is last in first out. So if you have any last in first out requirement, then you can use this data structure, okay, which is by default available in the collection framework. So if you look at in the collection framework, you can see all the data structures which were already implemented, and each of them is having some ready-made methods are available, right? So whatever the operations that we we write inside the C++ and C on our own, now it is already available, so it is perfectly implemented. So if you want any one of them directly, you can make use of that. Okay, and the implementation is optimal implementation only. So if you are right, so this is optimal implementation only. But only thing is the operations are little slow in terms of the time complexity. And how I can create a stack object? So it has only one constructor, that is stack s is equal new stack. So there is no size kind of thing to this. Okay, and then there are some few methods you can see here. So like push method is there. All stack operation relevant methods are available here. Like you have a push method, and you have a pop method, and you have a peek method. Peek method. Now peek method is basically used to return the top element. So and it is also going to remove the element from the top. Okay, it is not just returning; it's going to remove that element. Remember. And so empty method is going to tell you whether the stack is empty or not. And you have a fifth method, that is if you want to search for a particular element in the stack, you can use search by using search of. So that object you can mention the object that you want to search, you can mention that, and it's going to return you an integer value. Okay, it means it is going to return you the position of that element. So if that element is not available in that case, it is going to return -1. So you can have a look on this program. So stack s is equal new stack. So I'm adding some few elements into this, like you can see here. So the push element, first element. So the second element that is pushed is B, and the third element that is C. Now you see this is the order like ABC, right? You can see. So this is insertion order is preserved only, right? The order in which the elements are inserted. So the same way you can see them. And then if you want to pop an element C, you can see s dot pop. The top element will come out. And then see what is available in the list. Yes, this is popped out. Okay, and then peek operation. So then what is the element that is now available on top of the stack? That is P. Now you will get the B. And then search for A. It is going to return you the position of A. And then search for Z. So Z is not available in the stack. That's why it is -1. So s dot empty. Still there are elements in the stack. That's why it is going to return you false. And you see there are 4 list implemented classes. One is linked in array list, linked list, so vector, stack. And then so the stack is the subclass of vector class, remember. So array list, linked list, so vector, stack. Okay, so each of the class has some few methods and properties. Those properties you have to remember. So the all list implemented classes common property is, so insertion order is preserved. So insertion order is preserved. So duplicate objects are allowed. Duplicate objects are allowed. Heterogeneous objects, it allows heterogeneous objects to be stored in it. And each of them is having some different data structure as a underlying implementation. For example, for the linked list, we are using W linked list as this. And there is one main difference between vector and stack. What is it? So one important property for the vector, what is it? Can anyone of you tell me? Can anyone of you tell me what is the important property of the vector class? So among all the objects, yes, ma'am.
It's dynamic nature, sir, vector.
No. That property is it's all growable. So any collection object which are the list implemented classes are all growable in nature. Okay, but whereas arrays are, if I ask you the difference between array and the collection objects, the only difference you can tell you is collection objects are growable in nature, whereas the size of the array is fixed. Now my question is, what is the speciality or what is the importance of the vector class? Now all the properties that I spelled out for the linked list, so array list and all, it is okay. That's okay. One common important point is that, what is it? So if you look at the vector class is thread safe, remember this. So it is thread safe. This point is very important, which eliminates you most of the people in the interview, right? Remember this point. They will not concentrate on everything. Only they concentrate on these kind of questions. You can see here in this slide, every method present in the vector class is synchronized. Every method present in the vector class is synchronized, and hence the vector class is thread safe. What is thread safety? Wherever you are writing the synchronized code, it means, so it is called as thread safe. Thread safe means only one thread is allowed to execute some portion of the code, right? So such kind of object the vector is. So if you want the thread safety and you want the properties like the insertion order is preserved, duplicates are allowed, heterogeneous objects are allowed, and the null insertion is possible, and you want this to be thread safe, so the obviously your option should be what? Vector. Okay, this is most important. They will ask you such questions. So, and then you see there are three kinds of cursors. We are talking about the cursor subjects here. So let me take this. See, what is a cursor? I have already told you. So assume that this is a some data structure or list implemented object. So either it can be a linked list or it can be a array, whatever it is. You have the elements like this stored. So the implementation, internal implementation, we don't know. We are just drawing this way. And if I want to traverse, so the element by element in the list. Like first, my requirement is I want to go to the first element. Okay, after that I want to go to the next element. I mean, moving a step ahead, right? Moving one step forward. So from this, I want to move here, and I want to do some operation on this element, and then from here I want to move to this element. I want to do some operation on this one, and I want to move this way. So for this, you need an object. So that object I call as iterator object, or so the people will also call this as cursor object. Otherwise, you can also call it as iterator or cursor. Any name is okay. There are three cursors which are used to iterate over these objects, like the list implemented objects or any collection object. There are three cursors are available. One is the first is enumeration is a cursor, and then iterator is a cursor. I mean, iterator is a cursor, and then list iterator is another cursor. So we will see the properties of each of them. You see the properties of the first enumeration. So we use the enumeration to get the objects one by one from the legacy collection objects. You can see. So the enumeration. So any cursor property is what? So for getting the element, I mean getting the objects from the collection one by one. So for that reason, you use the any cursor. So enumeration is basically used for iterating over which objects? You can see legacy collection objects. What are the legacy collection objects? So the objects, the collection objects which are introduced in Java 1.0, we call them as legacy. Anything that is introduced, anything that is introduced in Java version 1.0, we call them as legacy. So there are several legacy classes. So the compiler sometimes gives you warning when you are compiling it. So the reason is, so you have the most advanced version of alternative for this kind of this 1.0 classes. You can have a look on that. The compiler gives you suggestion that way, right? So if you want to use, so if you want to iterate through legacy classes, you can use this enumeration object, right? So in the first place, how I can get the enumeration object? So for example, so I have the vector. Vector is the legacy object which is introduced in 1.0. If I want to get the collection, this enumeration object on say a particular, I mean vector object, I can use on the vector object whatever you have created on that vector object, you can just call the method, so elements method. Then it is going to return you an enumeration object, right? So this enumeration object, so now this is what we call as a cursor. By using this cursor, you can iterate through vector, right? So this enumeration, the iterator has two methods. One is enumeration is an interface mark here. Enumeration is an interface. So actually this has two methods. One is has more elements and then next elements. So if you closely observe this, the same methods I can use for the string tokenizer there, right? So to iterate through, to move from one token to other token, I can use these methods, right? The same I can also use from enumeration, right? So there we use the enumeration object. So even the string tokenizer is also introduced in 1.0. So because of that reason, so the enumeration object is going to be used even to iterate the string tokenizer. Now, if you look at the vector is also a legacy object. Then, if you want to get the enumeration object over the this particular vector object, you can use the elements method, which is available in the vector class. So then the result is you will get the enumeration object. By using this enumeration object, you can iterate through that particular vector. It has two methods called, so has more elements. To know whether elements are there or not, because you are traversing from one end to the other end. So when you are moving forward, so when you reach the last object in the vector, so then after that you will not find any elements. Just this is a end marker identification method. Whether the elements are there, if the elements are there, then you do this process. No, it's like so reaching whether it is like finding out the end marker. Like in the file we are saying now, so whether this is end of file or not. End of file is what? It's an end marker. In the same way, as more elements method is going to tell you whether elements are there in that collection object or not. In this case it is vector. And then if you want to move to the next element, you can use to the next element method, right? So you can see here, so vector demo, enumeration demo. So I have taken a vector class and I have added some 10 elements to the vector. Now you can see all the 10 elements are displayed by using system.out.println. So this. Now I want to do some operations on this. I want to do some operations on the vector object. Now what I want to do is, now I want to iterate through list. Okay, so this is assume you have something like this. Yes. Okay. Now this is your list. So this means vector. So this is your vector object. So on this vector object, if we want to iterate through, yes, now if I say E has more elements, Now where is E? Now first on this enumeration object, enumeration is not pointing to anything initially. And I say, right, E has more elements, yes. So whether elements are there in this vector object, yes, elements are there. Now what do you want to do? You move to the next object, next. When I say next element, it's now pointing to the first one. Okay, now I have taken this element. Now what is this I value? Now here you see next element is taken. So because actually whatever you are storing is what here, so it is going to be an object here, right? So that object, what I am going to do is, but when I say E dot next element, it is going to return you the object. It is, remember, what is the value, what is the return type of this? It is going to be object. Remember. So now I want to get the integer object. That's why I am typecasting it once again. Right? Now integer I is equal. So typecast it to integer E dot next element. Why we need to? Because we are storing only integers. We are storing integers and again we are typecasting to integer. What is the reason? Because E dot next element is going to return you what? it is going to return you object. I will show you the proof. Yes, you can see here, ma. What is the next element returning here? Next element is returning object, right? So I cannot do any operation on that. That's why I typecasted to integer. Now I got this because anyway, so auto boxing, unboxing concept is available. Now I can interchangeably I can use. That's why I percentage 2 equal to 0. I am testing it whether it is a even number or not. If it is even number, I just want to print that. Okay, I just want to print that object. Okay, so here that is my requirement. Yeah, I percentage 2 equal to I modulo 2 equal to 0. Then so it is going to print you 0, 2, 4, 6, 8, 10. Okay, so it's going to be done for all the entire list. Like it starts from here. First it will take this element and so apply the modulo 2, so and print it. Again the cursor moves here, so again do the modulo 2. So cursor moves here, and so at the end the cursor moves here. Yes, this also taken and then printed. Next, if I say next element, next before taking the next element, what I have to do, whether element is there or not, I have to check first. Okay, whether element is there or not, I am going to check first. How I can do that? E dot has more elements. Yes, elements are available. Then I can do what? Yes. If I say this is false, yeah. So when I say X again, so I am at this position. When I say he is at next cursor moves here. Has more elements? No more elements. So that immediately what I am going to get? So immediately, so I'll come out of the loop, and then if I print, so one important observation is, so inside the loop, you are just printing that value, remember. So your object is not going to be changed at all. You are just taking an element and testing and just printing here. So that's why you are just printing the even values. And then again, if I say system.out.println of v, so I am going to get my entire collection unchanged. I am going to get my, so the vector object unchanged. The reason is, so it has, I mean, this particular cursor or this particular iterator do not have any capability of changing the elements in the given vector object. From the vector object, only thing is you can iterate through them, and then you whatever the element that you want to fetch, you can fetch it or you can access it, do some operation on that, and then again in that way you can move on. So, but you cannot change anything in that. Just accessing is possible, but no way neither you cannot delete it, so nor you cannot add an element to that. Okay, so this is, and you see the best limitations I will tell you. So by this time you would have understood. So we can apply the enumeration concept only for legacy classes. That is, so the limitation. Legacy means all things that are introduced in 1.4. Sorry, 1.1. Right. So that's why 1.0 or 1.1. So that's why it's only the this is one disadvantage or limitation, and that's why it is not the universal cursor. Why we do not call this as universal server, universal cursor? So the reason is, no, we cannot apply this on the all collection objects. Only it is limited to few objects, like vector I can apply. So I can also apply for the, what is it, string tokenizer I can apply. There are other few objects, only for legacy classes I can apply. And so here you can observe here, we can read only access to the list. It means you can access only the element, you can access the element from the, so array object by using enumeration, but you cannot make any removal operation or you cannot make any replacement operation on the existing list. Okay, so to overcome this limitation, you have another kind of cursor introduced in 1.2. So that is what iterator. Iterator is another cursor. It has some better advanced feature. Only the difference is, you can see here by looking at the methods. Can you tell me what is the advantage of this over the enumeration? By looking at the methods, you please tell me. So the behavior is same. The behavior is same, and then this collection object we call as a universal object. It means you can apply this on any collection object. It's not limited to the legacy classes. Legacy means the introduced 1.0. It means we can use this iterator object on any collection object. Yes, I can use it. And the important difference is So you can perform removal operations on this. I mean, so if you want to remove some object from the existing collection, you can remove that. There is no problem. But so the earlier enumeration doesn't have such feature. Only thing it has only the read-only access, but you can read here, and if you want, you can also remove an element from that. And so this can, right? This has how to get the iterator object. You can see C dot iterate. C means any collection object. I mean, so I am not taking any example. That's why C dot iterator I have written. C dot iterator, it is going to return you iterator object. It has three methods. As next. So there it is to know. So it's a kind of end marker. So there has more elements. Here the method name is just changed. Has next. And to move to the next element, so here you have next method, there you have next element. Here you can see there is another extra method called public void remove method. Okay, ma. Remove method basically, so apart from the accessing the elements, you can also remove an element from the cursor. You see an example here. So I am applying this the cursor because I can apply on any object. So this enumerator, this iterator. So array list A is equal to new array list. 10 elements I'm adding to that. Now I am taking on this object, I am taking the iterator. I got the iterator object. Now before performing any operation, I have to always check. So whether elements are available in that. ITR has next method. It's an end marker test. Now, so ITR dot next. So it is going to return you the same thing like whatever the explanation I have given for the why I am typecasting. You can see. So the next method is also returning what? Object. So it needs to be casted to our type. What is the type? Integer type here. Now I am doing some operation on that. And apart from that, so what I am doing, so if it is an odd even number, you just keep in that list. If it is an odd number, you just remove that. So that is my requirement that I can use itr dot remove. Okay, I modulo 2 equals 0, it means even number, you retain that. And then if it is an odd number, I want to delete that. How I can do that? itr dot remove. Okay. End of the once it is done, you check what are there in your the array list. It is 0, 2, 4, 6, 8. Only even numbers are there because we have deleted. So the non-even numbers. That's why it is. Okay. And you have the thought limitations of the iterator. And the import both enumeration and iterator objects are so the single direction cursors. What do you mean by single direction cursors, ma? So it means it can move only in one direction. It means has next is there. So So next element method is there in the enumeration. Here next method is there inside iterator. It means so you don't have any backward movement for this cursor. So this cursor has only the forward movement. That is the biggest disadvantage. Okay, and then one more important thing is while iterating, so by using iterator object, we can perform only read and so the remove operation, but you cannot perform a replacement operation. It means you cannot do any replacement operation. Yes, if this is the you cannot perform any replacement at some particular position. So if you want to change, you cannot change by using this cursor. Okay, and so you have one more the cursor introduced, that is the latest cursor, that is list iterator. Okay, third one is list iterator. So now you look at the third one is list iterator. You see the list iterator is the child interface of the iterator. All these cursor objects are the cursor objects I am talking about is interfaces in the API. Remember this. These are the interfaces in the API, and this list iterator is extending from iterator interface. Okay, and the speciality of this list iterator is it can move so back and forth. It means it can move forward direction and also it can move in the reverse direction. It means it's a bidirectional cursor. Remember this point. It is a bidirectional cursor. Right. So forward movement and backward movement. So next. So you can also perform which operations? Replacement operations can be performed. Right. It means, and then new objects can also be added. So the existing elements can be deleted, new objects can be added, so and you can also perform the replacement operations. Then how do I get it? So the thing is, on any collection object, I mean, list. So on the list iterator, so no, and one more disadvantage I'll tell you about this. I should use this list iterator on only list implemented classes. That is the problem, right? It has the backward movement, it has the forward movement. You can add an element at some position, you can remove some element at some position, or so you can also remove an element at some position if you are not interested. And thing is, all the objects must be the list implemented classes. Otherwise, this cursor is not suitable for that. Now, if you look at here, there are 9 methods available. So there are 3 methods for the forward movement. Like you can see, next method. So next method, and then next index also there. I mean, because all list implemented classes are what? So all list implemented classes are index based. That's why you have next index method available. So here you can see has previous. Yes, it's backward movement. So previous, it will come back, and then previous index, it will also come back to the previous index. And then you have a remove method, and you have a set method. Remove method for deleting an element, set method for adding a new element. Okay, and then anything else. So all these things are available. Now you look at an example here. Yes, you will get an example here. So you have the linked list class, because I can apply this only on the list implemented classes. Okay, I can apply this only on list implemented classes. So I have added some string objects here. String objects. So we have added some string objects here. After adding string objects, if you look at these are the 4 string objects available in your collection. Now I want to take the iterator object over them. So L dot list iterator, you are going to get the iterator object. So after getting this iterator object, so I want to do some operation on this. Yes, no, yeah, itr dot next. By default, it is going to return you object. That's why it needs to be casted once again. Remember this point. And then s dot equals of this. You do this operation. Like this, you can do any kind of such operations like this. Okay, replacement operations. If you are doing this, yes, this is what. So removal operation, and you can see another operation like so the set operation. It means it is going to so replace. It is going to replace the existing object based on some condition. I am doing this, and then so again. So this is going to add element. Add method is there now. So add method is going to be used from the the collection interface. It is a list interface. You have the add method. That method you can use it. Now you see the difference between different collection objects here. Enumeration iterator and list iterator. So which of them are legacy? Am I audible, ma? Yes, ma. Yes, one of you please respond.
Enumeration, sir.
Yeah, so am I audible? Okay, I'm audible. Right. So enumeration is a legacy class, a legacy object, okay, or legacy iterator. Enumeration is an iterator, and which is legacy. Iterator is not legacy. List iterator is not legacy. And then where it is applicable for, you tell me. So it is so the enumeration is applicable for legacy classes. Iterator is applicable for any collection object, but so only list iterator is applicable for list implemented classes. You remember this. So this is universal. So this is for list, and this is for legacy. And you see movement. So enumeration objects only single direction, that is forward direction, and then iterator, this is also forward direction. List iterator, it is a bidirectional one. So how do you get this enumeration object? So you can use the elements method, and you have the iterator method here, and you have the list iterator method here. Accessibility, so it is only you can do only read-only operations. Yes, in the iterator you can perform read and remove operations, and then in the third one, so the list iterator is most advanced. So read, remove, replace, add, all the operations you can run. So the methods you already know. So you have the has more element. next element. As next, remove. And what are the methods available in the list iterator? So 9 methods are available. I have already shown you. You see all 9 methods. Add method is also there. Add method is from the collection interface or list interface. Any from there I can add the element. Okay. So this is list iterator. It's now 50, 11:50. Yeah, so now you see. Now, so after this, we have one more interface. I told you there are 4 interfaces. 4 interfaces are there. One is list interface collection. In the under collection framework, we have 4 interfaces, main interfaces. One is list interface. Next is set interface. So the third one is map interface. Fourth one is queue interface. So I told you set and list are under the collection interface directly, but the map interface is not part of the collection. It is given as a separate one. Okay. Now the second interface we are talking about is set interface. Okay. This is child interface. This is an interface of child interface of collection. You can see this in the hierarchy. You can see in the hierarchy. So the collection and then set interface. And then there are 2 classes which are implementing the set interface, that is hash set, and then another subclass of hash set is linked hash set. Next, another 2 interfaces are there, and then another class called tree set. So how many classes are there which are implementing the set interface? There are 3 classes. Only what is the set interface and list interface of this? Only thing is requirement is representing group of element, individual elements as a group, either by using set or by using list. Okay, so for this you have the collection, right? Both are collections. And then in which way they are different, set and list? No, only difference is there the insertion order is preserved. Okay, duplicate objects are allowed. So in case of set interface, these 2 are not available. It means it is where duplicates are not allowed, and then duplicates are not allowed, insertion order not preserved. You see here. Common property is what? Duplicates are not allowed, and then insertion order is not preserved. These are the 2 common properties that the set interface has. Remember, list interface, on the other hand, list interface, insertion order is preserved, duplicate objects are allowed. So almost. Okay, and then if you see, look at the set interface, 2 important properties. Or duplicate objects are not allowed, insertion order. So when should I go for the set interface and when should I go for the list interface? If a requirement is insertion order is not allowed, so insertion order is not allowed. I mean duplicates are not allowed, and the insertion order is not preserved is your requirement. Then you have to go for the set interface. Any of the class you can pick up and then you can work on. So if your requirement is insertion order is preserved and the duplicates are allowed, if that is your requirement, you can choose list implemented objects. Any of those objects you can use. Right? Here there are 2 interfaces here, sorted set, navigable set are 2 interfaces. And you can see the version is also mentioned here. So here there are no legacy because there is no 1.0. Okay? Few things are introduced in 1.2. Collection is anyway introduced in 1.2. Set interface is along with that. And then hash set, so linked hash set. So in the 1.4 they have added another class called linked hash set, which is a subclass of hash set. And then sorted set is an interface, which in 1.6 they have added navigable set. Okay, anyway, so we are not studying this class. Okay, navigable set interface we are not going to study, right? And then tree set is a class which is implementing both the sorted set and navigable set. All of you quickly go to the there ma. Yes ma. Yeah, all of you go to the so you please inform to your friends also. All of you inform to your friends that you have the exam at exactly 12 o'clock. You go to the LMS and then you can see. But don't do the call here. So one of you please confirm me, ma'am, whether it is accessible or not. Can you see the link there? One is set up at exactly 12 o'clock. One of you please confirm.
Sir, it's 12:10, sir.
Oh, it's 12:10. Oh,
Yes, sir.
sorry. Okay, then I'll take the attendance and then you will have some 5 minutes more. Right?
Okay, sir.
So, yeah. Yes, ma. Respond to roll call. Roll number 32, 18 batch.
Present, sir.
Next 121, ma. Same. Charishma.
Present, sir.
301. Sorry. 1,
Present, sir.
2, 3.
Present, sir.
Yeah. It's okay. 3,
3.
4,
Present, sir.
5,
Present, sir. 5.
6. Roll number
Present,
6,
sir.
ma. 7,
Present, sir.
8. 8.
Present, sir. 8.
Okay. 9. Roll number 9. 10,
Present, sir.
12, 10, 11,
Present,
11. 12,
Present, sir.
13,
Present, sir.
14,
Present,
15,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18, 18,
18.
ma.
Present.
19,
19. Present.
20,
Present, sir.
21, 21, 22,
Present, sir.
23.
Present, sir.
Okay. 22,
Present, sir.
23, 23, 24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27, 27, 27, Abhimanyu, 28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34, 34, ma.
Present, sir.
35, 35, no, 36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
41, 41, 41, 42,
Present, sir.
43. Yes, somebody is making noise, ma. Please mute yourself. 43,
Present,
40,
sir.
44,
Present, sir. 45.
45, 45, 45, 46,
Present, sir.
47, 47, ma. 48,
Present, sir. 48.
49,
Present, sir.
50,
Present, sir.
52, 51,
51 present, sir.
52.
Present, sir.
Okay,
Present.
50, 53,
Present, sir. 53.
54,
Present, sir.
55,
Present, sir.
56, 56, 57,
Present, sir.
58, 58, 59,
Present, sir.
181,
Present, sir.
182,
Present, sir.
301,
Present, sir.
302,
Present, sir.
303,
Present, sir.
304,
Present, sir.
305,
Present, sir.
306, 306 mark. Shivani. So the absentees you can check here.
Sir, 21 present, sir.
21 your presence. Yeah, okay. So
Sir, 27 also.
Chandama, roll number 8 is present or
27.
absent, you tell me. Roll number 9? 9
Nine
mark.
is present, sir. Her microphone is working.
Roll
number 8.
Okay, okay. So roll number
Sir,
23.
27.
Okay, 27, okay. Where you are, Abhimanyu?
Yes, sir, I'm here.
Why didn't you respond? Why you did not respond?
Sir, the connection problem, sir.
Okay. 23 ma? Swati? J Swati? Absent. And 35, Anok?
Sir, I had mic issue, sir.
It's okay. Next 41, Havas? Okay. Next 45? 45. Okay. So 47? 47. Okay. Next 56? 56. And then 306?
Sir, 306 present, sir. She is present.
Where is
Present, 306.
Okay. Right. Anyone?
47 present, sir.
47. What happened? Mirena, 47?
Yes, sir.
So, all you are writing exam, right? So, now you go there and then check it. So, the final absentees are 23, 41, 45, 56. Okay? Now you go ahead and then open it. So, I am configuring the exam at the second exam at.
Excuse me, sir.
Yeah.
Sir, 41 present, sir. I had to leave the class.
What?
41, sir. Roll number 41.
Emaindi?
Yeah, I actually had to leave the class, sir. There was a power cut, so I had to leave the class and join through mobile data.
Okay. 41. Okay, ma. Okay.
Thank you, sir.
Right. So now you can go and then access it. All of you can quit and then join there. So immediately I'm going to configure at 12:30. You can write the exam at 12:30. Okay. You can start this second exam at 12:30.